Okay, let's do it. Here, of course, we all know now that the lithium Kyber and Sphinx are gone, and we have MLDSA, MLCAM, and SLHDSA finally. So that means we're done.
Are we really done though? Does it really end there?
Let's go.
Maybe the panel claimed we were not done, but we think.
We think. Mm-hmm.
Okay, so here's the definition of cryptagility from the cryptagility risk assessment framework, where I'd like to just emphasize, to change existing crypto primitives, which of course now we're talking about RSA and EC, but quickly, inexpensively, with no or acceptable risk exposure. I think those are kind of key concepts for what the aim of cryptagility is. It's not to, just be able to do anything anytime, but of course you have to do a lot of things, but as inexpensive as possible and with as low risk as possible, because there's a lot of things going on. And we're going into a few details here, like, okay, for replacement of cryptographic primitives, we have, as we talked about before as well, I mean, for signature algorithms, it's relatively straightforward because they work the same. You can, if you previously did an RSA signature, you can now do an MLDSA signature. All right, and you can submit it through the same structures as long as Russ has fixed the RFCs there, which I see he's right about to publish. Right, but with CAMs, the initial process is a bit trickier. We need some new extensions to TLS and all the things because it doesn't actually work the same way as Diffie-Hellman. And you have to include things as key derivation functions and a couple of primitives that you didn't have to do before. And actually one piece of important information is there are multi-party protocols, which some people use. CAMs cannot do multi-party. They are always one-to-party or party-to-party. So for some use cases, there are bigger changes than for other use cases, definitely, and which is a little bit what we touched on in the panel this morning as well. I mean, you do testing to figure out all these corner cases which are not, the streamlined stuff, which are smooth, right? And when we talk about risk, there's, of course, things like, do you have to take the system offline? How can incidents be managed? How many migration processes can be automated? Automation is what the world wants, but it's not always in place. And will they create security risks themselves during a migration process? And, well, not the least, are there third parties? I mean, that's also one of the key points when we talk about what you can do today to prepare for migration is, ask every vendor and third-party supplier that you have where they are they ready? Can you get the software upgrades if you don't develop it yourself and such? So, well, maybe we should start with a poll here to see how many have asked if you have vendors or are relying on third parties. Have anyone asked them if they are ready for the migration to post-quantum cryptography?
Or we counter that too. Like,
there's
has anybody been asking for C-bombs from your vendors? We got one. Anybody on this side? Oh,
2, 3.
4, 5. Wow, a fair bit more than. Okay,
Yeah.
This is good.
We didn't, because we don't ask.
That's a good one.
It is. Okay, so there's, so some of you are doing the initial steps of preparing for migration. This is also encouraging. I would say this is a big difference from, say, a year ago. If we had asked the same question a year ago, I think we would have gotten less positive answers.
Could have got some blank stares too.
Let's see. Of course, I'm not sure. So I think many of you know kind of the basics of the changes of the PQC algorithms by now, right? When you move to PQC, you have to consider the resource costs here, which of course is the longer keys, the longer signatures, and the ciphertext, which are all bigger, which might have give latency on your network, might cause some old network equipment to break, might blow up your database size so it runs out of disk space or whatever. But also we talk about future standards, right? So you don't deploy cryptagility just for this migration, but also for if other more efficient algorithm comes along, a year or 2 years from now, you want to also be able to migrate from one quantum safe algorithm to the other. Migration, exactly. Key management systems. Oh yeah, I think I like this last point here, which is disposal. If you do migrate encrypted data and such, how do you dispose of your retired cryptographic assets or your old keys once you have migrated away from the things? There are so many different points once you start looking into it. So how many are considering using hybrid certificates? See, that's a bunch. Good. So definitely, the word is out on the street now if we should like hybrid or not, which we had a question on in the panel, but there is lots of pilots going on, and I just had a conversation just before this session around different types of hybrids. There's POCs where to test different hybrid schemes, or pure or hybrid or composite and all of these things. So this is kind of a list of the current ongoing work around hybrid certificates. One is the, formerly known as Catalyst, maybe futurely known as Chimera, do you think? No? That was tossed around in Austin, at least the name Chimera, but maybe it won't happen. Anyhow, we call it X509 alternative keys and signatures. And there's composites, which is an active draft, at least in IETF. It's moving ahead. So that seems to be certain to sooner or later, maybe sooner, come out as an RFC. And we have the Delta, also known as chameleon certificates, which is also a draft. I don't think it's moving very much.
They haven't asked for adoption.
Sorry?
They haven't asked for adoption.
Yeah. I think it's expired by now, but so we'll see if someone picks it up. But a lot of people like this one technically. And then we have related certificates, which is, not really a hybrid certificate, but it kind of is a mean to link two certificates together, which could be used for a classic and a PQC certificate. So everyone has studied all these different ways already? Yeah, okay. So you're bored already, aren't you?
Anybody have a favorite that they like?
Yeah.
No?
Oh,
Okay.
what's it?
No, you can always change your mind. That's why we have preferences.
It's everyone's smallest.
Yeah.
Exactly.
I guess I like composites, but probably the issue is backwards compatibility. So I guess in the first place we need to go with Catalyst.
I think that's a good answer. But it was also a good idea. I mean, we're allowed to have favorites, and every wise man knows when it's time to change your mind. Some they call it backwards compatibility, exactly. So Catalyst, Delta, and related are all extension-based, which we know can use non-critical extension, which means that if you don't understand it, you can ignore it, which is exactly kind of the attraction of something like or X509 alternatives, because you can. I've tested it. I've issued these certificates to Apache web servers and an Nginx web server, and a curl client, right? And it works fine. It uses RSA and it just ignores the PQC part. So nothing strange there. What else here we have? Exactly, and Delta is the same. It uses extensions, but it just works in a slightly different way that you, instead of just carrying a key and a signature, you can derive a whole new certificate which has the other key in it, which has some attractive features that you can have some different naming or different contents in the certificates. And they're related, which we'll see how that works. Well, we know how it's supposed to work, of course, but it's just how it would work in principle. So you issue one certificate, and it has I believe it's a fingerprint to point to the other certificate. So you know, well, if you trust one certificate, you're kind of implicitly or having an easier time to trust the other certificate because you know that they are related.
I look at that one kind of as derived model in the PIV world when they came up with the derived. You already have your PIV, and then we can authenticate with that to prove you are. Okay, let's give you a new certificate because we know you could authenticate off the old one. That's kind of how I look at it. No.
And then we have the issues, of course. All of them, well, there are some things that you quickly figure out when you start playing with it or start doing a PQC. That's what the standard is used. So delta and related also have attributes for use in CSRs, while for X519 alternative keys and signatures, there was in the old expired catalyst draft, which no one wants to talk about, but in the actual X519 standard, there is no mentioning of certificate signing requests. It just defines the certificate format. And equally, I mentioned this here, actually, the same comes from classic things which everyone or many people want to use, like OCSP. So when you start testing your hybrid PKI and, we want to test OCSP, then you're like, okay, but there is definitely no specification of a hybrid OCSP response. So then there are simple ways around it. You can consider, okay, maybe OCSP responses are short-lived, so we'll live with them only being signed with the classic algorithm for now, but then you also need to ensure that the policy or the clients that validate things don't try to validate it with the alternative key. So it becomes kind of some ripple effects across your ecosystem there. One thing that, this was actually David Hook here who wrote this slide originally. So he, of course, mentioned that all the mechanisms are transitional ones. So hopefully, in a past 2035 world, we don't need hybrid certificates anymore. So it's all these are typically, maybe except for composites, but all the extension-based ones are, to ease the migration effort. So we really have to make sure that they do ease the migration effort and don't hinder it, which I guess was NSA's argument for it, at least when I spoke in Austin in January, that when you start digging into hybrids and figure out things like OCSP and CSR and CRLs, then that actually will take time from you that you could instead spend on migrating your systems to pure. But that's, I think also it depends on your mileage will vary depending on your use cases. That's something we have learned over our many years of PKI, that even if I think something, there are probably relevant arguments why I'm totally wrong in a specific use case. Perfectly fine, valid arguments for that side. Okay, and now we come to, when it comes to specifics around this, when it comes to PKI and signing, we looked at some enrollment protocols to see how they, or how
who stacks up, or I guess who makes the cut and who doesn't?
When it comes to crypto agility.
I should have got a better line from the chopping block with that one. I wasn't thinking about that.
Yeah, exactly. We didn't have time to AI generate pictures for this one. That would have been good. And at least according to our investigation, CMP has a lot of years on its back, but it's amazingly, crypto agile design. Even though it's, I don't know how old CMP is. It's more than 20 years by now.
It's the Godfather.
Exactly.
You just don't get rid of the Godfather.
It uses plain signatures on messages, pretty small data. It has support not only for PKCS10 CSR, but also for certificate request message format, which has some unique features that PKCS10 don't have, which makes it super agile. Then we have EST, which is a simpler protocol. The biggest objection against CMP has often been the complexity, and it can be. EST is a lot simpler. It uses plain TLS, which is good. We know that TLS is agile enough, small signatures, but it uses PKCS10 CSRs, which are fine for signature keys, but not so fine for CAMs yet. The same with ACME. ACME was also a TLS and small challenges, perfectly fine, but PKCS10 CSRs are great for signature keys, which of course is the main use case, right? If you want an authentication certificate for your web server or devices, it's going to be fine if you use the signatures and P10 requests, but it will not handle CAMs yet. And then we have SCEP, which we have been hoping for a couple of decades now that it would go away, but we still have to suffer for it, which I would say it doesn't have any usable support for elliptic curves today, so I don't expect it to be much easier to handle with quantum safe algorithms. So I call that, well,
It's time to retire.
If this is grade A, then we have at least B, and fail over there. You can call me a SCEP antagonist, but
We can all agree it's got to go. It's time.
so hybrid PKI. Oh, well, CMC, because we don't implement it, so I don't rather not talk about it. That's fair, huh?
Yep.
I think, well, I guess CMC would also be, does it do CRMF?
It does both,
Yeah, so then that should be fair, pretty good. But it's definitely less used. I don't see a lot of CMC around. Not since, there was some Microsoft usage for it back in the days, but.
Oh, yeah. I think that's the only place I've seen it.
Well, they're being updated now.
Oh.
Yeah, I saw that. So someone is working on it, which, yeah, I mean, I think, well, I guess we can always use another protocol, can't we?
There we disagree.
Do you disagree against my irony or the fact? Okay, so when it comes to hybrid PKI, so of course there's currently only one standard out there until we get some more RFCs. Currently there is the X509 alternative keys and signatures. It's the only thing that is fixed, standardized. Of course, the old draft does have CSR support, so you can kind of mix it half standard, half draft. So we can generate CSRs with alternate keys and signatures and then send it and get the standard X509 alternative keys and signature back. So, of course, Bouncy Castle supports it and other things as well, like other libraries, OpenSSL soon, there's OQS and things like that. But there are likely dragons hiding once you start digging into this. I was talking to David Hook when I realized that OCSP couldn't be hybrid, and he, of course, said, well, OCSP have extensions. I can probably, I can spend 2 hours on it, and I can send you a patch for it if you like. And I thought, well, yeah, thank you, but I'll wait a bit anyway. So there are ways around everything, but you have to fix them as we go along. And of course, we wanted to kind of do some commercial for our EGBC EC REST client, which is an open source project on GitHub, which doesn't have support for. Technically, you can send a hybrid CSR through the REST API and get the certificate back, but the open source client doesn't have support for that. So, of course, we want to ask who for pull requests for that. No takers? No, I thought so.
Good old timeline.
Okay,
Maybe
exactly,
refresher.
good old timeline. Maybe we don't have to spend a lot of time. We all know the algorithms. There's round 4 going on for new algorithms, which is why we want crypto agility, because it's not going to be the last migration we do. There's a new signature round, as we also heard from Victor, who was part in submitting a couple of suggestions for that. There's, well, one that David Hook likes, you know, is a Sphinx Plus version based on ASCON, which he thinks is interesting. So, but I guess every cryptographer have their favorites. And as we said, the IETF drafts are almost finished. So now it's only, we never got to that question in the panel. So how do you say, are the the public key formats are fixed and good, but are the private key formats fixed yet?
The format's fixed.
The formats are
The
there.
format of language that goes with it is still being argued about.
Exactly. When we created these slides, the format was not fixed. So that was the last heated debate in order to be able to get RFCs, final RFCs out. But now, actually, during the last couple of days or the week or so, it has been, seems to be consensus. I hope that sticks like that, so we really can claim that we're ready to rock. And X79, we talked about that, and there are, as also Russ mentioned in the panel, you know, there's all these things which have drafts now. You know, there's certificates, there's CMS, cryptographic message syntax, CSRs, everything like that, which are really queuing up to go from draft to RFC standard. So hopefully, if we would have had this conference, you know, 1 month later or only a couple of weeks later, we would have, you know, lined up RFC numbers there, which would have been fantastic. But almost there, almost there. Of course, yeah, I think this conference, you'll see a lot about our solutions, so we don't have to talk too much about them. And I think we're getting some soon. Oh yeah, bouncy castle, which is one of the things which, you know, isn't so visible, you know, in a conference like this or in the advertisement, but it's definitely, it's the foundation of a lot of things. Bouncy castle is, I would say, doubtlessly today the cryptographic library or API which has the most things implemented in a production-ready way. So they do, the Bouncy Castle team does an amazing job in a number of areas. Of course, algorithms, you know, not only the NIST standards, but also the drafts and the working on coming drafts and such, and all the different formats. They implement not only the X79 alternative standards, but also the drafts for chameleons or delta certificates, composite, and everything like that. So you can, you know, play around with all of this. If you write code, Java or C#, you can play around with all of this with the Bouncy
And we got the
Castle.
Kotlin project too, where they can play with it easy for those who aren't so devy.
Yep. How many use Kotlin? Oh, no.
No? Okay.
But Java then? Well, a couple. C#? Well, even more. Cool. And yeah, all the protocols there as well, including TLS, of course. So this is all work which is done and you can use. So now we're coming to demos. So how we're going to explain the demo a little bit first. How we're doing on time, I think.
I think we got time. We're only
Plenty of time, good. So then maybe we should say, before we start demos, any questions?
Has anybody played with DGBCA to make a hybrid CA yet on your own? Few in the container?
Cool.
I have a question. You talked
Yeah, not really. I would say, I mean, TLS 103 or the PQC support is definitely done in a secure way, so you can't downgrade it, right? Or there shouldn't be any downgrade attacks against that. I think what you mean here, or what we or people mean here is, so if you have an X519 alternative keys certificate, and which has, say an EC or RSA as the default or the normal key, and post-quantum as the alternative. If a cryptographically relevant quantum computer comes along, it will break the RSA or EC, and it can then, of course, remove the extensions with the post-quantum algorithm and just create a new signature. So then the previously hybrid certificate is now a pure old-fashioned vulnerable certificate with only a classic algorithm. So that's, I think, the downgrade attack against a certificate like that. And if you have your authentication system will use quantum algorithms if they find the post-quantum keys in a certificate, but the classic if they don't, well, then they will settle on using the classic algorithm because the quantum safe keys don't exist in a certificate anymore.
So you're saying if I have a hybrid root and it's cross-signed to like an RSA, issuing or intermediate, then there's still a risk?
I would say so. I mean, because then, when RSA is broken, then these certificates, if the attacker can get their hands on them as a man in the middle or on the file system or whatever, then they can convert them from a hybrid to a normal certificate. So that's why, of course, the hope is that the migration is finished before a cryptographically relevant quantum computer is here, which is why we try to have all these different mechanisms to make migration easier. Of course, the nice property of these extension-based hybrids are that you can start issuing them, where you can have a hybrid, or at least a CA chain, which can be verified by either a quantum-capable client and a non-quantum capable client, right? So you can start issuing stuff before your whole ecosystem is migrated or updated with new software that are capable of quantum, which for many solutions will take a long time to be sure that your clients have quantum safe algorithms implemented. But it's a tricky one.
I have a question here from the chat also. Does OCSP still have a value with it going away for public certificates?
Absolutely, yes.
Can you expand on that?
Well, I mean, there's more private PKI than there's public PKI in the world, right? And you're always going to need revocation in the private PKI side, in my opinion. The public trust is just one use case out there.
And OCSP going away, or revocation in general in public PKI, relies on very short validity periods for the certificate. And I think many private PKI systems will not, in a foreseeable future, go down to 7-day certificates, for example. That's not going to happen for smart cards or SMIME or a lot of IoT devices out there.
Once we get robots to replace us, it could.
So yeah, but that's kind of highlights there is definitely different use cases where different things are needed. A public PKI have a very different set of requirements and use patterns than many private PKIs.
Any more? Huh? Oh, we got.
CRLs. So I had one of those CAs, and I just looked at it. It had the EC signature on it, not the. Is there any spec for CRLs moving forward, or is it?
Yeah, we've been exactly. So absolutely, you can create a hybrid CRL. I think Bouncy Castle actually does it, just that we haven't.
I just looked at the one that was automatically generated when I created the
Yeah.
CA, and it was just DC, but
So
maybe there's something.
It's just that we haven't implemented that.
Okay.
So it's our fault. As usual, Bouncy Castle usually does everything right, and then if something is missing, it's our fault.
Yeah.
So this is like, regardless of which hybrid model is chosen or what vendors or people choose, right? That's step one, right? We gotta get off of EC and RSA and we gotta get into this hybrid mode because the equipment can't just snap your fingers and everybody's stuff is changed. But eventually when vendors get to that point, and now we're kind of, to that gentleman's comment, we're operating in this hybrid state, which is at risk if quantum computers are now relevant at that time. Have you guys had any talks or discussions or with an IETF or anything like that for the next step to get to the final step where everything goes pure, right? And have you identified any difficulties there, or do you think that is going to be easy because the argument is, hey, the device or the server already supports both, so next time they come up for a cert and with the cert automation and renew it, we just give them a pure cert. I mean, is that the thought, or are there any gotchas there?
I mean, we kind of talked about that in one of our Keymaster videos last month.
Yeah,
about,
we did.
What is it going to take to go there?
What did we say? Do you
Well,
remember?
I remember some of it. We got to be on TLS 1.3. You got when C-bombs no longer show the classical algorithms anymore. That was 2, and I think there's one more.
Exactly, I don't remember that.
Marlon, do you
last
remember?
one.
No, I don't. I have written stuff about that. I don't remember the name. They didn't actually release.
And well, of course, if we manage to implement cryptagility now, then moving away from the, switching that when it comes in 5 years or 10 years should be a lot simpler than it is now if we're struggling. If we usually kind of say that it's good to take the opportunity with this migration to make your systems more crypto-agile, have automation or manage your trust stores so that you can, push out new CAs, upgrade software, and switch routes and things like that, and switch certificates more easier in the future. So if we manage to take that opportunity, then that time will, I think that it's an investment now, right? But I think that investment would be probably well spent because it will make our lives easier 5 or 10 years down the road. So we don't have to, be the ones who say, okay, well, I'm going to be retired when the shit hits the fan.
So I think the main challenge in the root CA certificate, so I think the end entity certificates is fairly easy, probably the intermediate CAs is fairly easy, but the trust anchors is something that you have to deploy, and if you have old versions, operating system, whatever, and then replace the trust anchors with new technology, I think this is the
That's
biggest
been
challenge.
one of my points that I bring up with a lot of the customers that I travel around and work with, because some of them are like, oh, it's going to take me 6 months or a year to push out a new route. I'm like, well, those days are gone. You need to be able to do that like in 30 days or less now. So you need to rethink your whole strategy on how you're going to do that, because with the crypto agility side, I don't think we're going to be in a case where you just have one route that's RSA or EC anymore. You're going to have all these different algorithm routes out there for the use cases that you have to be able to get those out there quickly. And yeah, that's the great point. I was going to say that after he stopped talking, but you beat me to it. So should we talk about the demo a little bit, what we're going to show?
Yeah, let's do that.
All right, so in the demo, we're going to obviously take EGBCA for a test drive, the container, EGBCA 9.2, and we walk through creating a crypto token for the root CA and the sub CA with the traditional, what did we do, EC keys? Yeah, I think we did P2, we did 521 for the root and 384 for the sub CA, and then we did the ML DSA 87 for the root, and then was the other one 65? Yeah, for the sub CA. And then with EGBCA, if you're familiar, we have the default key for the key wrapping. If you're doing key escrow for encryption keys, that's still using RSA, so 4096 for those ones until we get some ML chem in there to transition that part over. That's to be, you can ask the product owner back there. He's actually here, so any questions about that can go back to my cousin Magnus there. And then,
Yeah, it's 2 steps basically. First, we'll create this hybrid PKI with the root CA, sub CA, and be able to issue end-to-end certificates. We chose CMP because we thought about, well, it's most crypto agile, and we can actually issue MLCAM certificates.
with the proof of possession part now that it actually does the check with the chem, which is really cool because we faked that at the Tech Days 2 years ago, if anybody wanted to know.
And exactly, I think we have a slide that's...
Oh, the test drive, right? So we do have the updated test drive that Alex
That is
did.
the PQC lab here.
Oh, yeah, sorry, we have so many different ways to test drive this stuff. But yeah, the PQC lab, although Alex has to update the client for us that I forgot to tell him to do for that, for the 9.2 side. But yeah, you can go to the link there and download it and download the client and build this all out yourself too and play with it. And I think it's free 30 days, something like that.
Yes. So that's what we did for the demo, to actually use this public PQC lab instance just to see that it actually works. We didn't know if it would work, but it did. And so the second part of the demo is the MLChem, which we talk about, but we'll see what it actually does. So for that, we will configure to use CMP, and we will have this CMP client, which is a Java-based command line tool, which will be used to create a CRMF request, RFC 4211, which requests what's called indirect POP, proof of possession, because that's the problem with the CAMS and PKCS10 CSRs. So proof of possession, typically when you send a certificate signing request, is a self-signature. The public key, which is in the CSR, the corresponding private key adds a signature so that the CA can verify that whoever sent the request is actually in possession of the private key. That's proof of possession, which is not possible with CAM because CAMs cannot make signatures. They can derive encryption keys or exchange encapsulations, which you convert into AES keys. But then this CRMF have this fancy idea of indirect POP, which means the client asks the CA to send the certificate back encrypted. And the kind of idea is that, okay, if the client can decrypt the certificate, it obviously have access to the private key. If it can't decrypt the certificate, well, it won't get a certificate. So that's what we're going to see.
And then, well, we also did a TLS cert too.
Oh, that's right. We did a plain
we forgot to
signature.
put that on
We
there.
forget that.
Yeah.
So there will be one normal TLS signing certificate and one ML-CAM certificate.
We wanted to give you both sides, a little balance.
And I guess, in practice, ML-CAM certificates would typically be used for, SMIME, which today you can use RSA, and unless you're constrained by FIPS 140-3 restrictions, you could use that RSA key to both do the signing and encryption of your SMIME message, which supposedly a lot of clients do. But of course, that's not possible in a post-quantum cryptography world where you will need separate signing and encryption key. So, yep, I think that's it. So
that was the column
this
one,
is
wasn't
just
it?
some details which we can talk about. Right. So, okay, let's.
Now we got to put on the video. Okay, we got to go back there and switch it out real quick. Weren't that fancy to embed it in a PowerPoint slide.
So since we knew it would be tricky to
open the video.
run a live demo here with the setup, we recorded it. Well, last time I did this, I did a live demo on the keyboard, but it's better than expected. So let's see if we have managed to explain what's happening on the screen during the time. So we sped some things up. When it's repetitive tasks, we increase the speed so you won't. I don't think you will fall asleep. Yeah, that's it. So you explain it.
Okay. So the landing page we talked about where you can go try the trial out. So you go get the link and then click on the little accept and then click continue. And then since I don't have access, I guess, to that, as we'll see here, I just go around, but you'd go through however you get permission to actually go do that since I wasn't approved to do it. So then we'll kind of hop into actually having the EGBCA up. And yes, what do I say? Please approve. Yeah. And send it. I don't even know who approves it at the Keyfactor side for us. If it goes to Connor or Harry's group or who it goes to. So
you need permissions to start up things in Azure for your organization.
So we have proper checks and balances there, yeah. So then that goes.
That's an Azure thing.
So then after it's deployed, you get the landing page here, and we go into the admin web. So we click the little exception because it's got the cert for the management CA. And actually, we got to create our P12 first. So it's already set up with the Keyfactor admin, and there'd be a wizard you'd have gone through that to put in the password.
This is the administrator for
Yeah.
EGBCA.
So we'll go some serious classicness with a nice RSA 2048. And you get that, and we'll install it in the browser so we can do the MTLS connection in. And as I locate the certificates and go to import the P12. I actually have to say I did a good job timing this as I go along. It was actually funny. We recorded it once, and then we realized we weren't actually recording when we were doing all of it. And we're like, okay, we wasted that. Had to go redo it. All right, so we get into admin web. And it's already got the MLDSA stuff we did for the tutorial 2 years ago, I think. And so the idea here is creating the hybrid root that we talked about.
So first it creates what we call a crypto token, which is creating the keys.
Like the overlay of it.
Now this is what we mentioned. So here we actually create the keys in software, which is not production. Good, but it would look the same if it was an HSM.
So we go find the P521. So that's our classic, and then we'll do the, I think, what do I do next? Oh, test key, okay. And do a little P256.
Now that's one key that EGBCA uses just to check the connection with a HSM, for example.
And good old classic.
So that's a optional key, which is used for encrypting some stuff in the database, which currently doesn't support MLCAM. So that's a future feature.
There we go, and then we drop down way to the bottom. At least the post-quantum's easy to find now. You just scroll all the way down, and it's right there. We make it easy to use. So we repeat really quick here to do the sub-CA. Same exact thing. It's even faster if we did config dump too and did that. So then we'll go in and we create the cert profiles. I'm just going to end up cloning the ones we did for the MLDSA because all we have to do is then just add in the alternative signatures in those. So it's pretty simple to do this too. But I'm having a problem, I guess, deciding which one I wanted to do. But you know how it is. Oh, and then we'll clone the sub-CA as well. Then we'll go edit it. And then it's already set, so we change it to the EC and then the P521.
So this sets a policy limit so that it will only allow EC 521 for the root and MLDSA 87. So you cannot create the roots here with any other algorithms there.
And then we set the alternative signature, so it's easy to do the two keys now. And then everything else is all the same, so we're just going to save it. And then we can go edit the sub-CA. And the one lesson I learned from this is that you actually need to make the signature algorithm match or use the issuer one instead for that option. So that had that, but we're going to change that to the very top option. Otherwise, we get a fun little error in there, so you inherit from your issuing CA.
That's because the root CA signs its own certificate, but the sub-CA certificate is, of course, signed by the root CA. So whatever the algorithm the root CA uses will be used on sub-CA.
Once we get here, we can actually go create a CA. So we've got the profiles, we got some keys. We'll go and create our root CA. So we give it our nice little friendly name, and then select our root crypto token. And then our signing alg. And then set our alternative signature. There, then we can set our CADN.
You don't trim this, right? We can't do this in the cloud.
Yeah, this is actually running in the cloud. I forgot, I actually said container, but I forgot we'd actually use the cloud instance.
Right, but an average user can get to it?
Yeah. And if you can't, call me.
No, it will.
So I love the phone calls. I gotta have something to do. All right, so we make that, and then we open up 2 other tabs to go grab the CRL and the certificate location, so we can copy those URLs and put it into the root CA. That way we can just pull the CRL from EGBCA and the CA certificate, so everything shows up nice in there.
Yeah, Sven does things a lot more production-like. When I did a demo on my keyboard, I did the ugliest, I minted bad certificates. Sven mints good certificates.
I'm a purist, okay? Like, we want the right extensions. I dealt with a product that put a lot of bogus extensions I didn't like in it before, so I'm very anti-bloat. Okay, so sub-CA, yeah, then it's really repeating the same process. Subordinate, grabbing the URLs, same drill.
Adding additional words to that.
No, it already did that. Oh, well, you mean like certificate policy OIDs?
Yeah.
Oh, you could do that too, but I don't have. Actually, who owns the OID arc at Keyfactor? I want my own OID so I can start carving out my arc. So we could actually do some proper policy.
Oh, it's in Confluence. You just add your.
Is it?
No, that's a prime key. Old
Yeah,
one.
that's what I'm saying. Who owns the Keyfactor
So,
OID?
well, that should be compliance.
Okay.
We
I
have
get to ask those guys.
Nice compliance department nowadays.
So then we're cloning the TLS server. So then, we went with 47-day to kind of go. We're following the CAB forum recommendations there with our buddy Clint.
Exactly. No one should use TLS certificate has longer validity than 47 days, right?
Because why would you? It's such a great number, 47.
I can ask Clint like.
So for a little jest, we're having fun with that to do that. And besides, we're going to use Acme, right? So it totally works. It's all automatable. It's no problem. So everything's set there, and then we go save that. And then do we go create the S-MIME one? So we'll just copy. I think I copied the authentication one, if I'm not mistaken. There we go, yeah. So we'll do that. So the S-MIME one that we do is the one that will be the CMP side for that second part of the user enrollments. So we'll do the MLChem 768, and then we just leave that, or no, that's actually got to change to the MLChem part too, or from the issuing CA, yes. And then, oh, we had a little debate about that one too, right, on the key usage. I was going with key encipherment, and Tomas was like, we need to do data encipherment. I'm like, are you sure about that? And we're going to have to edit that out of the first video. So this is why we did re-record.
Yeah, but then I looked up the actual internet draft and it said key encipherment. I was sure it said key exchange.
I'm like, that doesn't make any sense. So and then we clone the entity profiles. If you're not familiar with EGBCA, you have an entity profile that ties into your certificate profile in the CA, creating this really complex web of how you can manage your certs. So definitely put a little thought into this if you're going to go with it. It can get pretty fun. So we edit that. I think maybe go change the DN structure, and then all we really got to do, that's an important one too. You need to check the batch generation for the CMP for the S-MIME. Otherwise, that's not going to play well. Change our OU to Tech Days 2025, and my country code of ZZ, since I'm no longer a country. Then you can add another one too, required at least, so we have an email in it. Oh yeah, then we require the email up there to make it easy to fill in, and then update our cert profile. And our hybrid CA. And then user generated, obviously, because with a chem, you're never going to generate server side. I assume, right? Like you never ever generate a chem server side.
You would, absolutely. If you want to use
never mind, retract.
key recovery.
Oh, that's true. But you haven't built that in yet. So it's still coming. Totally forgot about that. And then this guy is just a DNS name, so he's all staying the same. And then just change the cert profile to our hybrid now. And then our hybrid
Exactly
CA.
here, I mean, this is signature certificate here. You would never want to use key recovery.
Right.
For CAM, for an encryption, you could definitely use key recovery, which means you have to store the private key somewhere on the CA in this case.
Okay, then we add our RA alias, so we'll just call it SMIME.
This is for CMP. Exactly.
Or actually, no, we did go to client mode. That's right, because we added it. So the quick difference, CA mode, it needs to be existing in EGVCA. It's not using like a shared password or your cert to come in and authenticate to get you're pre-registering it in EGVCA to use as your enrollment to come in. And then we set the default state to our hybrid, and we click save. And then we go and add our user, I think at this point. I don't actually remember if we go over to the TLS one or if we do.
This was a breather.
Yeah. Oh, we had to download the client. Okay, so we do that next because we have to make our CSR. So we download the zip, and then we get that over here to unzip.
Exactly, so this will do the TLS certificate first with a hybrid TLS and then the certificate and a whole hybrid chain.
So then we get the client unzipped. And then we're going to actually generate the CSR, so it'll be this big old command. Or actually look at the help first, because there's a lot of syntax to this. So it's easy to grab this, copy and paste, and take it to a text editor to do the command. So it's all here. All of it says MLDSA, so if you see the dilithium, you've got the wrong client. And then we go and get the big command to generate our CSR. Oh, actually, I made a directory first. And I do that because then the way the cleanup works on that, the way it's doing the cert names, it didn't actually change it to whatever the common name was requested, so it was just easier to do it from inside that. And then generate the CSR now.
So which uses MLDSA 44 and ECP 256, right? Wasn't it?
Yeah, P262, yeah. And you can see the CSR is about quadrupled in the size compared to what we're used to. So it's a little bit bigger, but nothing to be scared of. And then we go to RA Web and log in. Now we can do an enroll and select our TLS hybrid. Paste in that nice big old CSR, upload it, and then just copy the DNS name
Exactly.
or the username.
Exactly, there it says that it's what's the
ML.
2 algorithms in that CSR.
And then we can download that. And then go parse that with some OpenSSL. Can you guys see that in the back of the room, or is it too small? Because we got into a little bit of debate about how big the text should be in this.
I wanted bigger because I have old bad eyes. He wanted smaller because he's young.
And now I'm saying, okay, I'm like, oh, I can read it, but then I'm like, oh, what about the guys back there? So then the big thing here, you know, you've got the traditional pieces, but now you got the .72, 73, and 74, which are the alternatives there. So the extensions are here, but obviously a Mac on the version I run has no clue what I'm talking about.
So there's 3 extensions, one for the public key, one for the signature algorithm, and one for the signature.
Okay, now we got to go to the RA functions and add an identity for the SMIME. So we select our cert profile, or identity profile actually in that case. And then we're going to use Mike Kushner, one of my dear friends at Keyfactor, that I figured would be fun to use. So you guys can spam him with his email coming up here if you want. So we put in the email address and then the common name, and then we do add, and then at that point we can go grab, we'll go over to the CLI part to the CMP client that's in there and run that and point it up to our instance in Azure there to enroll for our MLChem. And then you want to walk them through all that fun stuff like you did with me again the other day?
Yeah, there's sets here, creating protected PKI message, and it says used in CMP, and then down here it's actually have received the answer, and it says decrypt and return certificate with private key of type MLChem 768. So, and then we parse that certificate, and it has the same things. Well, this one has an MLChem key, which, this old version of OpenSSL cannot read, so, it can read it, but it can't display. And then we have the 73 and 74 only, which are the alternative signature algorithm, alternative signature, which is put on the CA. This doesn't have an alternative key because we created a pure MLChem client certificate, but signed by a hybrid CA. So there's plenty of combinations you can do here and combine pure or hybrid.
Yeah, and I think that's it.
Question for me, the how-to guides that we have in our documentation, are they applicable to this specific game or is this adds on a little bit, right?
I mean, they're pretty applicable. I mean, just be cloning the profiles to do hybrid now selection, adding the alternative signature in. I mean, we could update it and do that.
So we have actually how-to guides on our online documentation that just set up the hybrid PKI and
Yep.
hybrid certificates. So
And actually, I could,
those are available today, so we can just update them.
I can use this whole video to make a tutorial out of it and do a regular voiceover.
Exactly. This is a little bit more production-like than the tutorial, and of course updated. I think the tutorial has dilithium because it was recorded
2 years
before August 13 or before October 24 when it landed in Bouncy Castle.
Yeah, did we do that? I know we did it in January, but was that January 23 or 24? The one that Alex and I did with the original one on the peak post-quantum web. So it's 23.
No, it was 24, but not 25.
Okay, I'm gonna have to go look at my plane tickets to see. I don't remember.
So,
Oh, we got a question from Jaime.
So I guess what you've produced here is a catalyst certificate.
Yes.
And I didn't see any option where you could choose what kind of hybrid certificate you have. So is Catalyst the only thing that you're supporting as of today?
Currently, yes.
Plans for
Good question.
favorite.
Yeah, when are we gonna get some composite love?
Was was composite your favorite?
Composite?
Huh?
Yeah.
Yeah.
For my plans for my favorite one, it was composite.
Yes. So it's not roadmap to a date, but definitely it's the one we see. It's the next that's going to be standardized. So we definitely see a path that we will probably have to implement that. We've kind of leaned back a bit, waiting for standards to settle before we dig too deep into it. But yeah, we see that coming.
So my previous answer was the right one.
Yeah. But you can do it with Kotlin if you want before to play with that side with the. But yeah, we don't have it in this one yet.
Exactly, the Bouncy Castle has it, right? We just need some new UI options, as I say, to say which type it is and things like that. Yeah.
Are there also plans to, for these tutorials, to commit it on GitHub, so you can go and
We would
provision it with the Helm chart, for example?
for the. Well, I don't know about the help. I mean, we would do the tutorials on the docs.keyfactor.com. They'd be there, and then there'd be a YouTube video for this. But then for the Helm chart,
Well, if it starts the EGBCA container, then you can do it exactly like this.
yeah, I mean,
Yeah, the question
Through an
why
init
is
container.
because we are doing the same thing almost. And
Yeah.
if you have recommended tutorials or recommended steps, then everyone can reproduce it or reuse it.
Yeah, absolutely.
Yes.
I mean,
Yeah.
it will be the same, once you have started it, it will be exactly the same.
Exactly, it's
Yeah.
the same instance, so you can
Yeah,
reuse the code you have already created.
definitely.
So maybe we can follow up on that.
Yeah, I was gonna say, let's
How exactly
follow
we
up.
do that, and then we can sort of scan. Maybe I can just scan your, so I remember.
Okay, great.
So that, but I think we actually don't have time for more questions now.
What?
What?
Oh, she's right.
Thank you, Sven and Thomas, for the presentation.
Thank you.
Thank you.
Appreciate it.